Let us look at the next important one, which is marine litter or marine debris. As defined by UNEP, marine litter is any persistent manufactured or processed solid material discarded, disposed of, or abandoned in the marine and coastal environment. So this is the biggest problem we are actually currently facing from the plastics. The marine debris, according to Honolulu strategy, includes plastics, metals, glass, concrete and other construction materials, paper, cardboard, polystyrene, rubber, rope. All the list is given here. In some instances, marine debris may also be a vessel for dangerous pollutants. So these are all the various definitions of marine litter. And the next one is the microplastics. Microplastics has been the focus for the ongoing debate for its size, because some scientists say that any items less than 5 millimeter in diameter is called microplastics. But some other scientists say that the term is should be used only for less than 2 millimeter or less than 1 millimeter or even less than 500 micrometers. So these are all various scientists' suggestions, like what is called a microplastic. Depending on the upper size limit, industrial pellets may or may not be included in this particular term. The microplastics are basically categorized into primary and secondary. So what are primary microplastics? The definition is, these are purposefully manufactured microplastics designed for specific functions. What are secondary microplastic? These result from the breakdown or wear of larger plastic. So that is the major difference. For a purpose you make, that is primary. If it is obtained after some wear and tear, then that is the secondary. So what are the sources? Basically, the primary microplastic is produced and used in the various products and processes. But in the case of secondary microplastic, many of our activities are responsible for this. These are generated from the degradation or wear and tear of large plastic items. So anything and everything belongs to this particular category. How these are transported? Basically, the primary microplastics are transported as pre-production pellets or resin beads between manufacturing sites, whereas secondary microplastics are not transported. They actually originate from the breakdown of larger items only. And usage, everybody knows. Environmental impact, when we look at the primary microplastic can enter the environment during use or disposal, whereas the secondary microplastic result from environmental loss or breakdown of larger plastic items. So this is the most problematic one. And what are nanoplastics? Currently, from the micro, we are moving to the next smallest one, which is the nanoplastic. So these are basically a subcategory of microplastics created by the degradation of larger plastic items. But what is the difference? The difference mainly exists in the size. So some definitions use a threshold of less than 1 micrometer, and others range it from 1 to 1000 nanometers. So this is the couple of definitions that exist for nanoplastics. They have a very high surface area to volume ratio. So that is the reason they are even more problematic one. They enhance the ability to absorb organic pollutants and other hazardous contaminants. So not only they are problematic, they also take more pollutants like organic pollutants onto them. So that is the reason these nanoplastics are really a problematic one. They have colloidal behavior. In other words, the particles unintentionally produced presenting a colloidal behavior because they are so tiny. They form like a very, very tiny suspension in water. So that looks like a colloid. And these are basically having polydisperse in nature, in their physical properties, and they are heterogeneous in composition also because they came from various types of material. So we cannot say they are homogeneous in nature. The formation is basically the heteroaggregates with the natural and anthropogenic material due to their colloidal nature. And these currently we do not have enough scientific information to prove that these nanoplastics are actually problematic to the ecosystem. But what is the difference? These nanoplastics differ from nanomaterials which are currently used in various applications due to the production pathways and physical and chemical properties. Because nanomaterials are basically new materials which are produced at the nano level. Even our computer chip is having a nano chips, we call them, because silicon wafers are having very nanometer thickness. But in the case of nanoplastics, they are basically pollutants. So if you look at the plastic sources of plastic litter in the marine environment, the marine activity is only 20%, but the terrestrial systems actually give lots of pollutant to the ocean. So one is from rivers, storms, flooding and tsunamis. Especially the coastal tourism, recreation, marine industry, commercial fishing, all these are responsible for the plastic litter. So how do we detect and study the marine plastic pollution? One is ocean trials, another one is biological sampling, beach combing, marine litter observation, sediment sampling and sea ice cores. So what are the ocean trials? This is basically the method to use to zooplankton nets or water samples. From that we can actually find out. The purpose is when we catch these things, zooplanktons or water samples, we detect microplastics in the water column or the surface of the ocean. So there are some of the challenges in studying or understanding that. One is the variability in the mesh shape affect the results. Then it also requires multiple transects and repeats to account for natural ocean heterogeneity. Because if we just collect some water sample and say that there are plenty of nanoplastics, but if we go to a different place, maybe that area is not having enough microplastics. So that means there is a huge heterogeneity, and this is a major problem in our studies. And biological sampling, we can do dissection of marine animals to quantify the plastic ingestion. How much plastic is actually present in the marine species or marine animal, we can study. And basically northern fulmar is one of the important species lots of scientists are studying about, especially with respect to microplastic pollutions. Why it is important? It actually provides insight into the plastic pollution through ingestion patterns, and the data can be used in international legislation also. The second one is the next type is beach combing. So this is here we regularly collect a plastic litter from the beaches. The advantage is it is very simple and effective method of measuring macroplastics. It is not microplastic, it is basically macroplastics, and the limitation is it is less effective for microplastics, and it is challenging in Arctic region due to accessibility issues because we cannot reach Arctic every day. And marine litter observation is basically the records by boat crews or remotely operated vehicles or divers we can use to study the marine litter, how it is present. And the limitation is it again focuses on macroplastics only. Microplastics are hardly recorded. And for example, the Arctic deep sea observation at Hausgarten recorded an increase in the marine litter, but only down to items less than 10 centimeters. So this is how we can actually find out how much pollutants, basically the plastic pollutants are entering the Arctic region. The next one is the sediment sampling. So here the materials are collected, the plastic particle from the beach, estuary or seafloor sediment using high density saline water or an elutrian device. We can collect the sample. We can use fluorescent spectroscopy to find out the plastic components what are present there, and we can also do sea ice core mooring. So here the melt and filter sea ice to extract the quantity of plastic pieces. So once we take the ice core, we can actually melt it to see how much microplastics or macroplastics are present there. And the current status is only very few people study about this. There is benefits or has to be validated, and here we can also use the fluorescent spectroscopy to identify the pollutants.